Hi friends, welcome to follow-up, and in this video we are going to look at today's daily challenge problem 238, product of array except self. The strategy for this problem will be partial product, so you can compare this with partial sum or compare with prefix or suffix sum. So here let me change this one to be or. Right, but mathematically, if you consider product, it's essentially the same to consider partial sum if you take logarithm, right? So that's just a set comment. So here we are given an integer array called nums. So we want to return an array answer of the same size, where answer I is equal to the product of all the elements of nums except nums I, right? So here the requirement is that we do not use a division. So we can for sure use multiplication, right? But we want to do it in a more efficient way. So let's digest one example. So we are going to look at example 1. So notice that in example 2, there is 0. So if you include 0 in a product, for sure it will give you 0. So that's why, in example 2, so we have 4 zeros and have one none, right? So that's a sort of special. Now let's come back to example 1. So to the left of 1, so there's nothing. So we regard it as 1. And the right, so we have 2, 3, 4. So the product is 24. Right? Similarly, you can check 2. So the left is 1 and the right is 12. So you have 12. So similarly, you can interpret 8 and 6. So here, the constraints are the following. The length can be as long as this one, right? And this is the range of nums. Can be positive, can be negative, can be 0. So the product of any prefix or suffix of num is guaranteed to fit in a 32-bit integer, right? So here is a follow-up. So can you solve the problem in one extra space? And the output array does not count as extra space for space complexity analysis. So we are going to use ON of space in this video, and then we are going to comment on this follow-up. So with that said, we are ready to continue. So here, our goal is that for each index, say I, so we want to compute the left product before I, right? Let me write like this. And then also the right product after I, right? Then the answer corresponds to this one will be nothing but the product of these two, right? So this is subject to index I, right? So before I, right? So that will be our full logic. But if in order to get these two pieces of information, so we can use partial product, right? So in order to get these two corresponding tables, so these are ON temp complexity required. So we can do it quickly. So first, in order to for convenience or to type length nums, so I introduce this variable m. So let's initialize this one. This is the m, the length. So this left going to, for each left I, means product before I, right? So I'm going to do a right. So this means right I means product after I, both not inclusive, right? So here, I guess, in order to get these two tables, so it's just the caution is to pay attention to the indexing, right? So I'm going to set left 0 to be 1. The reason we set it 1 is because we are doing product here, right? Then we are going to iterate. So for I in range, so we start from I and ending at the last index. So the left I will be the following. Left I minus 1. So this is to the left. So we can write this like I minus 1 because we start I from 1. And then we multiply nums at index I minus 1. Same reasoning. Here I minus 1 is a valid index. So this way we are going to get left index, left product. So similarly for right, we are going to set n minus 1 or last element to be 1. Then we are going to iterate reverse in the reverse order. So we are going to from n minus 2. Then so we use an increment -1. In other words, we decrement 1 each time, and we end before -1. In other words, end at 0. So the right will be something like this. So because we look at the right side, so it's right I plus 1 times nums I plus 1. So here I plus 1 because we want to the product after index I. So here I plus 1 are always valid index because we start from n minus 2, right? So this is the same as I minus 1 here. So once we have this two pieces of information, so we can do the return. So at each index, so we can multiply the left part sum and before I and after I, right? So this is very simple. So we get A times B for A, B in, so we use zip function for two iterable, so left and right. So this provides one format of solution, right? So let's do a run. Yeah, it passes a first example. Now let's look at the generic case. Yeah, it passes all the cases very quickly. So in order to further digest, so we can actually print out, so left and right. So we can use a new line here. Now let's run it. So you can see for this one, to the left of 3, we have product is 2. To the left of 4, we have product is 6. So similarly, you can look at right. So now we finished that, but for this problem, we used ON of 10, right? So the follow-up is, can you solve the problem in O1 extra space? So in other words, we don't want to compute this part when we do the computation. So actually, so you can think of this. So I'm going to leave it here as an extension. So use O1 space to include the information in the two tables, and left and the right. So I guess with this main idea explained, this will be rather straightforward. So with that said, I guess that's basically about it for the current problem. So you are welcome to comment and share this with your friends. Thank you.